Are you interested to solve problems on digital logic circuits? So this video is meant for you. Let's start the video with a MCQ type quiz. Here with each question I will give you 3 options and 10 seconds for each attempt. Let me know that how many questions you have correctly answered. So start the video. If you are interested to get this type of stuff or to watch tutorials on electronics, please subscribe Electronics with Expert. Now let's move on to some subjective problems on digital logic circuits. Problem number 1. Implement the function of a 3-input NAND gate using only 2:1 marks. From the truth table of a NAND gate, we know that when all the inputs are equal to 1, the output is 0. So here only for A equals to B equals to C equals to 1, the output will be in 0, and rest of the cases the output will be in 1. So this is the truth table for a 3-input NAND gate. To implement the 3-input NAND gate by using a 2:1 marks, I have already drawn a 2:1 marks. As you know that for a 2:1 marks there are 2 inputs named as I0 and I1, and there is only one select line, that is S, and this is the output Y. Now as we can see from the truth table that when A, B, C all of them are equals to 0 and AND gate output will give 0, that means I0 will be selected, and from the truth table of this 3-input NAND gate we can see that Y is 1. So we have to put I0 equals to 1. So I have connected plus VCC with I0 input. Now let's check it. For A, B, C, all of them are equals to 0, that is then S0, and that means I0 is selected to the output, and from the NAND gate truth table we see that the output will be 1. So if I connect it with plus VCC, then it means that Y should be 1. Now for A, B, C 0, 0, 1, then again the AND gate output will be 0. That means again it will select the I0 input, and here from the truth table of the 3-input NAND gate we can see that here also for A0, B0, C1 Y equals to 1, and that means we have exactly connected the AND gate with the select line. Now the last case for A, B, C all of them equals to 1, it will have output 1, and that means it will select the I1 input, and from the NAND gate truth table we see that output is 0. So I have to connect it to ground, that is when A, B, C all of them equals to 1, then output will select I1, and that is 0. So this is the way we can implement a 3-input NAND gate by using a 2:1 marks. Isn't it interesting? Okay, let's move to the next problem. Now this is again an interesting problem regarding marks. and the problem statement is design a combinational circuit using 4:1 mux and other necessary logic gates that detects an error by outputting 1 for 6 non-BCD codes and 0 for the BCD codes if the inputs to the combinational circuit is a 4-bit binary input. If W, X, Y, Z are the 4 variables to represent BCD and non-BCD codes, then the non-BCD min terms are. So these are the 6 non-BCD min terms I have written here. This is W X bar Y Z bar, that is this represents 10. This represents decimal 11. This is decimal 12. This is decimal 13, this one is for decimal 14, and this is decimal 15. So these are the 6 non-BCD codes. From the statement of the problem we find that output will be 1 for these 6 terms. On simplification I get this. Now the next step should be W X Y bar Z bar, W X Y bar Z. The third term can be reduced as W Y Z bar, and the fourth term can be reduced as W and Y Z. Now this can be reduced again and we can write it as I0 Y bar Z bar or I1 Y bar Z. This is I2 Y Z bar, and this will I3 Y Z. So here I0 is WX, I1 is again WX, I2 is W, and I3 is again W, keeping in mind that the select lines should be YZ. So the circuit looks like this. This is a 4:1 mux, where this is I0, I1, I2, I3. These are the select lines S1, S0. We have connected with Y and Z. This is the output Y. Now I0, for I0 it should be connected to WX. So I have taken an AND gate in which the inputs are WX. Again for I1 it is equals to WX, so I have connected this one. Then I2 equals to W, I2 equals to W, this is I1, this is I2, and this is I3, and again I3 is also equals to W. So this way we can implement the function. If you like this video, please let me know by commenting here. To watch more tutorials on digital electronics, you can check this playlist or you can watch these videos right in this channel. And thank you for watching.